Hello everyone, I'm Dr. Vilayat Khan. In this lecture on microprocessor system and interfacing, I will give you a brief overview of the historical background of the computer systems and in particular of microprocessor systems. Microprocessor based systems are everywhere. They are used in telephone and mobile phone, and personal computers and washing machines and robots, for example in fuel systems, petrol pumps, and everywhere. So they are being used in many components of our daily lives. A typical computer system, we need to understand a typical computer system where a microprocessor is part of a computer system. It is just an example to understand microprocessor based systems. In a typical computer system, there is a microprocessor, and there are output devices, there are input devices, and there is a memory unit. In the microprocessor part, there is hardware component, arithmetic and logic unit. Arithmetic and logic unit of the microprocessor is responsible for calculating arithmetic and logic operations. Arithmetic operation can be addition or subtraction, and logic operation can be comparison of two values. For example, one is less than the other, or one is greater than the other, or if two values are equal or not. Similarly, there is a control unit. This control unit of the microprocessor is responsible to generate control signals, and with these signals, the microprocessor is able to control all other components. For example, it can send control signals to the arithmetic and logic unit whether to perform addition or subtraction on the arguments. Similarly, there is an array of registers. The number and size of the registers depend on the microprocessor. We will talk about more about the sizes of the registers in different microprocessors in the later part of this lecture. So inside a microprocessor, there is an arithmetic and logic unit responsible for performing arithmetic and logic operations on the data, and there is a control unit that generates control signals to control different components of the microprocessor, and there is a register array to store data for the arithmetic and logic unit to perform different operations on that data and then store the results in these registers. And to get data from the external environment, there should be some input devices. For example, the input device can be a keyboard, can be a mouse, can be a scanner, and there are hundreds of different input devices. Input devices are connected to the microprocessor so that data can be given as an input, or data can be read from the external environment inside the microprocessor. That data is temporarily stored in the register array, and then the arithmetic and logic unit performs logic or arithmetic operations on that data. And obviously, to make it useful, the microprocessor would give the results to external environment through the output devices. So there can be a number of output devices that are connected to the microprocessor. Among the output devices, it can be the screen, the display, for example, your monitor. It can also be a speaker, for example, to output the voice, or it can be any other form of a device. For example, it can be an Ethernet to send data through a network, or it can be other form of output device. So, and the fourth component is the memory unit. In the memory unit, a computer system stores data and programs, these programs and data can come to these registers for execution if they are instructions or programs, or if it is a data, then data is moved to one of these or many of these registers for the arithmetic and logic unit to perform on it. So memory unit is responsible to store data and programs. Programs are executed by the microprocessor, and the data is where the arithmetic and logic unit is to perform arithmetic and logic operations on. So memory unit is responsible to store data and programs or the instructions of the program, and input devices are to read data from the external environment, and output devices are to output the data that has been computed to the external environment. So this is a typical computer system. If we compare this typical computer system with a mobile phone, then in a mobile phone, the touch screen or the keypad or the mic is the input devices, and inside the mobile phone there is an arithmetic and logic unit, control unit, and register array, and the output device is the screen where we can see the output, and the speaker, for example, is an output device, and inside the mobile phone there is a memory as well. That memory is used to store programs and data. So we can map this typical computer system world to a number of other systems. Okay, so let me give you a brief historical background of the computers in general. Computers in the mechanical age, it was a simple form of computer was used about 500 BC and by the Babylonians, the ancestors of present-day Iraqis. They used the tool abacus. Abacus was just a simple computing tool that was used to count things, for example, to use subtraction, for using subtraction and addition. It was just a stained up beads organized in different rows and different colors. And for example, if we had to subtract, for example, if there are 10 beads in one row, and if we want to subtract 3 from 10, then we had just to push 3 beads on the right hand side, and then we had to count the beads on the left hand side. So there would be 7, so we would just perform a subtraction of 7 minus 3. So this was a simple calculator, and then later on it was used until 1600 when Blaise Pascal invented a calculator. This calculator was a mechanical calculator, fairly mechanical calculator, which consisted of gears and wheels, where each gear had 10 teeth. And this calculator was so powerful that even it is being used in the odometer nowadays as well. So it was a simple calculator, but it could be used for calculating values. After the mechanical age, we then entered to an electrical age, where Hollerith machine was invented in 1889 by Hermann Hollerith. And this machine, Hermann Hollerith, used a 12-bit code that could be used to store data on a punch card. Hermann Hollerith machine was so popular that it was used in the US Census in 1890. Then in the electrical age, another computer, Anyak, was invented, which was electronic numerical integrator and computer. ENIAC was invented in 1946 by the engineers on Moore School of Electrical Engineering at University of Pennsylvania, United States. ENIAC was the first general-purpose programmable electronic computer. It was general purpose. By general purpose, we mean that it could be used for different calculations. It was not designed for a specific purpose, but it could be used for different or multiple purposes. This electronic numerical integrator and compute calculator was so big that it was consisted of 17,000 vacuum tubes, and it contained 500 miles of wire. It had 6,000 switches, about 100,000 operations per second. That was the speed. It is nothing as compared to the modern day computers, but at that time it was so fast. It weighed 30 tons, so huge, so heavy. The main problem with this computer was hardware programmable. It would need rewiring, switching for a programmer to fit it or to make it fit for a different program to execute. Then the programmer would rewire or changes switches inside the computer to make it operational for a different purpose. Because vacuum tubes were used in this computer, and the life of a vacuum tube was about 3,000 hours, so it would require frequent maintenance because of the life of vacuum tube. Apart from other problems that it was so big, it needed hardware programming, which is too difficult and cumbersome. The concept, stored program concept, was introduced by John von Neumann. By the stored program concept, John von Neumann meant to store programs in the memory unit, just like the data. Before, there was hardware programming, which was too difficult. With the stored program concept, a program, which is a set of instructions, could be stored in the memory along with the data, and a computer has to read instructions from the memory one by one and execute them. So with this concept, if a program is to be executed in a computer, then just write set of instructions that would make the program, and that set of instruction is to be stored in the memory, and the computer has to execute instructions one by one. So if anyone has to execute a different program on the same computer, then the programmer would just change the set of instructions in the memory and not the hardware programming. So as compared to the hardware programming, this software programming was so flexible. It was easy to be modified. Then in 1958, Jack Kilby of Texas Instruments invented integrated circuits. The invention of this integrated circuits was so significant that it led to digital integrated circuits, and then digital integrated circuits led to RTL logic, and register to transistor logic in the 1960s. Intel then introduced integrated electronics in 1968, and they continued and introduced 4,000 family of hardware components. In 1971, they started with 4001, which was a 2 kilo ROM with 4-bit input and output port. Then 4002, which was a 320-bit RAM with 4-bit output port. 4003, which was a 10-bit serial and parallel out shift register, and a 4004 4-bit microprocessor. Programming advancements with machine language, Actually, it was set of binary codes, and each binary code would represent an instruction. For example, an instruction would be just a sequence of zeros and one, and this language was called machine language because it was so close to the machine, the computer. Only computer could understand it easily. For a programmer, it was so difficult to understand the sequence of zeros and one, or even to remember it. So initially, there were machine languages, which were just binary codes to represent programs. Programs in machine language were easy for the computers or the machines to understand, but it was so difficult for the human being to understand and remember. To facilitate this, assembly language was introduced. In assembly language, there is a mnemonic code for the instructions in binary. For example, for a sequence of zeros and one to represent an add instruction, they introduced mnemonics. For example, ADD to add two operands. ADD are the English letters of the addition, which is easy to understand. So assembly language was so easy to program in as compared to machine language. However, it was not that much easy to write very complex applications as we need today. So then high-level programming languages were introduced. For example, in 1957, Grace Hopper introduced Flowmatic. Then later on, IBM in 1957 introduced Fortran, which was a formula translator. Language COBOL, computer business-oriented language, RPG, report programming generator, and then BASIC, C++, Pascal, Ada, Visual Basic, and we have a number of languages. So these high-level programming languages facilitate programmers to write complex applications very simply, and then there were other tools which are called translators or compilers to translate the programs in high-level languages to machine language. So compilers make the programmers able to write complex programs without looking into the internal detail of the microprocessor or the machine language. In 1971, Intel invented the 4004 4-bit microprocessor. 4004 was the world's first general purpose microprocessor. This microprocessor had 4096 memory locations, with each location had only 4 bits, which is called nibble. So its memory was 4096 nibble. There were 4096 locations, and each location could store only 4 bits. So in other words, the memory that it could support was just 2 kilobyte. It had 45 instructions, which is a very small set of instructions as compared to modern microprocessors. The speed of this microprocessor was just 50 kilo instructions per second. It could execute 50,000 instructions per second, which is again very low as compared to the modern microprocessor, but at that time it was so fast. And compared to the Anyak computer, it was so tiny that it could just weigh an ounce. Later on, in 1972, Intel introduced an extended version of 4004, the microprocessor 8008. It is an extended 8-bit version of 4004, and in addition, it could support 16 kilobyte of memory, while the microprocessor 4004 could support 2 kilobyte of memory. Then in 1973, Intel introduced 8080 microprocessor. It was the first modern 8-bit microprocessor at that time, and in addition, this 8080 microprocessor was 10 times faster than 8008. In addition, it could support 64 kilobyte of memory. So as compared to 404 microprocessor, which had 2 kilobyte of memory, and then 8008 microprocessor, which could support 16 kilobyte of memory, 8080 could support 64 kilobyte memory. Then in 1977, Intel introduced 8085 microprocessor. This microprocessor had 246 instructions, and the speed of this microprocessor was around 769 kilo instructions per second. In addition, it had internal clock generator and system controller. 8085 microprocessor was so popular that Intel sold over 100 million copies of this microprocessor. In the modern microprocessors, Intel introduced 8086 microprocessor in 1978, and then 1 year after 8088, which is again a 16-bit microprocessor. So this microprocessor had 2.5 millions of instructions per second speed. The speed, of course, improved as compared to the previous microprocessors. Both of these microprocessors could support 1 megabyte of memory because it had an address bus of 20 bits. So 20 bit could be used to address 1 million locations, and each location was 8-bit wide. It had higher execution speed and memory. IBM sold the idea of a personal computer in those days, and in their personal computers, IBM used 8088 microprocessor. Then later on, the Intel introduced an extended version of 8086, the microprocessor 80286. It is again a 16-bit microprocessor. It was almost identical to 8086 and 8088 microprocessors, but the memory that it could support was 16 megabyte memory, and the speed that it had at that time 4 millions of instructions per second. Then Intel continued, and they introduced 32-bit microprocessors, and this category 80386 was one of them. Then later on 80486, and then they continued by increasing the sizes of the registers in the microprocessor. They introduced 64-bit computers, Pentium, and the story still continued. Let me introduce some concepts. RISC computers, which are reduced instruction set computers. In the RISC, there is a small number of instructions, which is normally less than 128 instructions. So 128 is a very small figure. So if a computer has just less than or equal to less than 128 instructions, then it is considered to be in the reduced instruction set computer category. Then compared to RISC, there are CISC computers, which are complex instruction set computers. The main difference between RISC and CISC is that in RISC, the number of instructions are less than 128, and in CISC, there are complex instruction set. Another difference is that in CISC, there is a single instruction in correspondence to multiple instructions of RISC. For example, if there may be an operation that is performed by a single instruction in CISC computers, but the same operation may be performed by a number of instructions in the RISC computers. In CISC, there is a large number of variable length instructions, multiple addressing modes. We will talk more about addressing modes. And a small number of internal processor registers in the CISC computers, and the CISC instructions that require multiple number of clock cycles to execute. So there are a number of other features that normally CISC computers have. In this table, there are modern Intel and Motorola microprocessors. Here, we can see that Intel has a number of microprocessors in their family. For example, 8048 was a microprocessor that had 8-bit data bus width. The data bus included 8 lines. The memory size was 2 kilo internal memory, and 8051 8 kilo internal memory, and similarly 8086, which had 16-bit data bus while it had 1 megabyte of memory. Similarly, 8088 had only 8-bit data bus, and it could support the same memory as 8086, 1 megabyte. And the story continued until Pentium and nowadays to core, dual core, and so on and so forth. Similarly, on Motorola, they started with 6800 microprocessor, which had 8-bit data bus. It could support 64 kilobyte of memory. One trend that is clearly visible with these microprocessors is that the data bus is normally increasing. The width of the data bus is increasing. The memory size that the microprocessor can support is increasing. And the same trend is happening in the if we just look at the Intel family of microprocessors that begin with 4004. The first microprocessor of the Intel family, 4004, which was invented in 1971, it was so small that it was just included up around 2000 transistors, and the external data bus of this microprocessor was just 4-bit. There were 4 lines. It could carry or transfer just 4-bit of data at a single time. The internal register width was 4. Address bus width was 10. With these 10 address bus lines, it could support 1 kilobyte, 1 kilo locations. The size, the speed is given here in the megahertz. There was no onboard coprocessor, there was no internal cache memory, and these are the voltage requirements. With 8080 microprocessor, which was invented in 1974, the number of transistors increases. Internal bus width is 8-bit now. Internal register width is 8. The address bus width is increasing. The speed is increasing. So, if we look at the trend in the Intel family of microprocessor, the internal register width is increasing, and normally this value is the size of the microprocessor. For example, 4-bit microprocessor or 8-bit microprocessor. So by that, the normal convention that is used to represent if a microprocessor is 4-bit or 8-bit or 16-bit is actually is normally the number of the widths of the internal register in that microprocessor. So the internal data bus is increasing, the internal register width is increasing, the memory that it can support is increasing, the speed is increasing. The number of bits in the internal registers or the internal register width is increasing. This is important to store higher number of bits in a register. Similarly, if the external data bus width is increasing, then the microprocessor is capable of bringing more data at the same time. So these are the parameters that are very important for the increasing efficiency of the microprocessor. These features are responsible to store more instructions or to store large instructions in the memory. And of course, there are a number of other features as well that are responsible for increasing the processing rate of the microprocessor. A few more words about 8086 microprocessor, because this was the most popular microprocessor of Intel family. It is a 20-bit address. It has a 20-bit address bus. With these 20-bit address bus, it could address 1 million locations, and each location with 8 bits, so 1 megabyte of memory. The instructions that it had were 20,000 variations of instructions. If we compare this value with the 4004 microprocessor, which was the first Intel microprocessor, general purpose microprocessor. They invented this microprocessor in 1971. In 4004, there were just 45 instructions, while in the later microprocessor 8085 microprocessor, there were just 246 microprocessor. So these numbers are very small as compared to the number of instructions or variations in the 8086 microprocessor. In addition to the number of instructions in the 8086 microprocessor, 8086 had separate bus interface and execution units. These two units were responsible to fetch an instruction, while the other was responsible to execute instructions simultaneously. So there were two units. So one is responsible to fetch an instruction from the memory, while the other could simultaneously execute the instruction that had been fetched before. It had 16-bit internal processor registers. Each register was 16-bit, with the ability to access the high and low 8 bits separately if desired. For example, if the 16-bit register is used and if the high byte of that 16-bit register is to be accessed, then this microprocessor would allow to access that high byte of the 16-bit register. Similarly, the low byte could also be accessed separately. It had hardware multiply and divide built-in units for multiplication and divide operation. It had support for an external math processor, which could perform floating point math operations as much as 100 times faster than processor alone via software emulation. This is a simple diagram that represents the two units, a separate execution unit and the bus interface unit of the 808 microprocessor. We have a general registers, 16-bit registers, and we have arithmetic logic unit that is responsible for arithmetic and logic operations. There are flags. So this execution unit is responsible to execute an instruction, while in the bus interface unit, it is responsible to generate addresses, and it could locate an instruction in the memory to bring it inside the microprocessor. So this bus interface unit is responsible to fetch or bring the instruction from the memory inside the microprocessor, and this execution unit is responsible to execute an instruction. With these two units, an instruction cycle can be divided into two phases. For example, the bus interface unit is responsible to fetch an instruction, while at the same time, if there is no instruction to execute, then the execution unit is waiting. And when the bus interface unit is done with fetching the instruction, the execution unit starts executing that instruction. While the execution unit is executing the instruction that has been fetched by the bus interface unit, the bus interface unit fetches the next instruction, and this continues. 8088 is a 16-bit microprocessor. It had 16-bit data bus. The 8086 had 16-bit data bus, but the 8088 microprocessor had 8-bit data bus. In 8086, it had the requirement of two separate 8-bit memory banks to supply its 16-bit data bus. It was quite expensive memory chip at that time. IBM announced their personal computers in 1981, and they used 8088 microprocessors, Intel microprocessor, in their personal computers. They used 16-bit memory, which could be expanded to 64 kilobyte of memory with the clock speed of 4.77 megahertz. So it was these personal computers were quite popular, and they were using the Intel 8088 microprocessor. So there are a number of other microprocessors, 32-bit microprocessors, 80186, 80386, and then Pentium 1, Pentium 2, and then modern microprocessors of the Intel family of microprocessors. So I'm not going to talk more about these microprocessors in this lecture, and we will continue more about the significance or the applications of the microprocessors and the internal structures of the microprocessors in coming lectures. If you have any queries while watching this lecture, please note those queries and questions, and you may ask those questions in the online session. Thank you.